Okay, stop me if you've heard this before. Wait, you really can't stop me because this is a one-way video. But anyway, humor me for a second. There it is. It's Friday afternoon. You're furiously working on a report for the boss who's breathing down your neck and absolutely has to have it by the close of business that day. And you're madly typing away and suddenly, poof, your network share goes down and your file is gone and all of that work is lost. Naturally, an email comes in from IT saying, "Sorry, folks, looks like our file server is down. We'll have it up as soon as possible. Looks like you're working another Saturday. Lucky you." What if there was a better way to do this? What if there was a way we could put file shares out there that were always up, no matter what? Hey there! Thanks for joining me on this walkthrough video of ActiveCluster for File on FlashArray. I'm Don Poorman, technical evangelist here at Everpure, and I gotta tell you, this feature that we've released has been the most requested feature since we had the ability to deliver NFS and SMB file shares a few years ago on FlashArray. And now it's here. So what are we gonna cover in this Pure 360 video? Well, first, I apologize, but we are going to have some obligatory slides on getting to know ActiveCluster for Files, how it works, what its configuration looks like. We're also going to include some slides that are dedicated to Murphy's Law, which is what happens when things break in your ActiveCluster for File configuration. And then we're going to sit with Quinn Summers, who's put an incredible demo video together that talks about how you configure it, how you manage it, and ultimately what it looks like when you do have a failover event. So with that being said, let's dive in and kick the tires on this feature. Okay, before we get into the demo, let's do a really high-level view of what to know about ActiveCluster for File on FlashArray and some of the things that need to be in place before you actually are able to leverage it. So let's start with why ActiveCluster for File in the first place. Well, the value proposition is pretty simple. It's a synchronous zero data loss replication. The Mediator itself can be hosted either internally in your data center or via Pure One. And there's approximately a 10-second failover from one site to the other, which is definitely industry leading as far as time is concerned. There's also the fact that ActiveCluster functions across two arrays themselves, and there are geographic limits to it as well as latency requirements and bandwidth, but it's an active standby architecture, and the standby array has a mirror of the data, metadata, and the configs itself. And the user experience, it's built right into the GUI. Everything that you know how to do with ActiveCluster is also available with ActiveCluster for File. Fusion is also an option to use here as far as setting things up across a fleet, and there's automatic array failover. Now, what about the protocols and clients? Well, the supported protocols are what you would expect: NFS v3, v4, SMB, SMB continuous availability, and multi-target DFS with DFS Direct. But the client operating systems must be within the FlashArray file services support matrix for those protocols. You can find that on our support site. All right, now that we understand the value of why ActiveCluster for File, let's talk about some of the prerequisites. First off, there are the obvious things, right? You need two FlashArray systems, whether they're X's, XLCs, or E's. You're going to need Purity 6.12.x or better, which is a feature release version of Purity itself. Both of your arrays obviously have to support ActiveCluster synchronous replication, either via IP or fiber channel. And they all have to be enabled with these prerequisites. Now, the Mediator, you can either host it in Pure One, or if you don't do that and you have a dark site or it's just not something you would do, you can host the Mediator virtual machine in your data center itself. The networking, well, from an IP perspective, 4 replication IPs are required per array, and the ports on the array have to be capable of seeing each other. So the primary's got to see all the same 4 ports on the secondary one. If you're using fiber channel, you also need 4 dedicated fiber channel ports for that replication, with the same idea that they all have to see each other between the active and the passive node itself, and you have to have the replication service turned on. For latency and bandwidth, since this is synchronous, we are a little more sensitive on latency. You have to be less than 11 milliseconds as far as latency is concerned, and have enough bandwidth size for the amount of stuff that you will be replicating. That's obviously something you can monitor into through the dashboard in your FlashArray itself. And as far as the management ports are concerned, all the management ports on both arrays are all connected so they can reach wherever your Mediator is, whether it's local or if it's up in Pure 1. The other possibility here, which we highly encourage, is that even though Fusion is not a hard prerequisite, we still encourage its use as far as being able to manage into fleets and multiple arrays and things along those lines. But the way this works is you still could just do this through the GUI on the individual arrays themselves, as you'll see in the demo. With the prerequisites out of the way, let's take a look at the higher level of what ActiveCluster for File looks like. Obviously, we need two arrays to be able to do this. So we've got a flash array that acts as the active array. We have another flash array that acts as the standby. They're both connected, like we said in the prerequisites, via IP or fiber channel. And then there's a third component in this. And in this case, it's the Cloud Mediator that's hosted in Pure 1. The Cloud Mediator itself acts as an overseer and ensures that should the active array suddenly not become available, things get cut over to the standby array. But in the case of what we're looking at right here, this is what happens when it's working normally. Your SMB and NFS clients have read-write access to the file system and managed directories on the active array itself, and everything via synchronous replication is mirrored over onto the standby array itself. If there is a failover, the Mediator will detect it and cut over to the standby array and redirect all of the clients as well. If there's a failback event after that has happened, that's going to be handled by your policy, whether it's automatic or manual itself. And again, in the case of what you're looking at right here, the Mediator is actually hosted in Pure 1. That's why we're calling it the Cloud Mediator. Okay, so you've seen what it looks like when Pure 1 is hosting the Cloud Mediator, and this is what it really looks like when there's an on-site Mediator as it relates to configuring ActiveCluster for File as well. See, there really isn't much of a difference here. The steps are all the same on the right there. The biggest difference is that your on-site Mediator is actually configured locally to connect to your management interfaces and runs as a form of a virtual machine in your environment. All right, it's the moment of truth. What happens when the active array fails in an ActiveCluster for File scenario? In the case of what we're talking about right here, before I get into it, we are just going to refer to the Mediator itself. We're not going to discern between Cloud Mediator or on-site Mediator. Anyway, in the event of a failure, the active node goes down, the end clients can't see their shares on that active node. The Mediator will then, within 10 seconds, redirect all of the NFS and SMB traffic to the new array, which is the standby array itself. That one becomes the active array, and the Mediator continues to monitor the two arrays to see if the active one comes back up. And if it does, the failback is either automatically handled or manually based on the policy that you've set inside the GUI. If you're an IT professional, you know that you are occasionally going to get hit with situations that you never planned for. So let's take a closer look at some things that could happen to your ActiveCluster for Files configuration under the banner of Murphy's Law, that anything that could go wrong will go wrong. The first Murphy's Law scenario is actually pretty straightforward. What happens when the Mediator goes offline? Well, if it were to go offline, everything still continues to operate as designed. The active and standby nodes will still continue to work with each other in a synchronous replication fashion, and the end clients will still be able to reach all of the data shares that they are accessing on the active array as well. The second Murphy's Law scenario is something much bigger, and I think if it happens, you've got bigger problems to deal with. But what happens if the Mediator and the link between the two arrays goes offline? Well, the Mediator goes offline and the active standby can't communicate with that link down. What's going to happen is neither side is going to be allowed to continue I/O to avoid the split brain problem, because we don't want these arrays out of sync with regards to data integrity between the two. Which means the hosts themselves, the end users, are going to lose access to those stretched volumes until the connectivity to the mediator or between the arrays is restored. That's kind of a worst case scenario and really the second Murphy's Law example. And there you have it, a really good high-level overview of ActiveCluster for File, the prerequisites, what it looks like logically, and what to expect in various failure scenarios. Let's see it in action with this demo video that Quinn Summers put together.
Okay, so with that being said, I have two simulators up and running right now, VFA1 and VFA2. They're relatively brand new systems with almost nothing on them. So we are going to begin by connecting these arrays. So I'm going to go to protection. I'm going to go and create an array-based connection. So I'm going to say connect the array. Here, we're going to enter into the IP address of the secondary controller, which is this IP address. We're going to choose synchronous replication. We need a connection key, which is as easy as going over here, going to protection. This is the secondary array that I'm on, by the way, and I get connection key. So this is the shared secret between the arrays that will allow this replication link to share the metadata and the user data synchronously across the both arrays. So now we have just created that brand new sync replication array link. For the next step, what I want to do is I want to go ahead and create a realm. A realm for ActiveCluster for File is our container for our file systems that we want to stretch across both arrays. So in this instance, we're going to go ahead and create a realm called realm1. That is good. And then I'm going to go ahead and stretch that realm right now. Stretching is the verb that we use to say, I want to synchronously mirror everything with this in the container, or this realm1, to my remote array, and anything inside this container will not look like duplicates of each other. It would just look like an up-to-date version that's stretched across both sides. So we go in and stretch that. I hit refresh, and now we can see both things should be in the online state. Excellent. So we have stretched our realm. The next thing that we need to do is that we need to configure a server within that realm itself. So our servers are our protocol endpoints. They are how we access storage. So I'm going to go to storage. I'm going to go to realms. I'm going to go to realm1, the one that we've just created. Over here, we have no servers created or configured. So we're going to go kick off our server wizard by clicking on this plus button. This is a guided workflow. We're going to create a server name. We're just going to keep it really simple. For test purposes, we hit the next button. Here, we're creating the virtual interface that is going to be accessed by our applications. I'm going to give it a Purity storage name called sync file. This is just an internal name to Purity. I'm not going to select VLAN tagging, although we will support that. I'm going to specify my IP address and my gateway. So this is the IP address and my gateway of the virtual interface that I want to float between both flash arrays that are synchronously mirroring the file system. Sub-interfaces, these are the physical Ethernet ports that I'm going to choose. And the drop-down menu, it gives us pairs across both controllers, CT0 and CT1. That looks good to me. I'll go ahead and select that. The next step is setting up DNS. I'm going to use our default DNS settings on this array. And then for directory services, for the purpose of the demo, I'm not going to use user mapping. We're going to just trust the client's credentials or whatever they pass us. I hit the next button. It gives the preview of the actions to create this server, and then we hit create. And so now this wizard will issue these API commands, configure this for us, and then looks like we're done. Okay, so we have a server up and running now with our IP addresses. Next, we need to give it something to actually access. And so let's go to our realm. We'll go into our file systems. We'll create the plus button to create a file system. Let's give it FS1. Hit the create button. All right, we have a file system. Now we need to create an export policy that we can access that file system from. So let's go to here, we'll go to policies. I'll create a new export policy. My realm, I'm going to select the realm that we created, realm 1. I'm going to name this, name the policy open. I'm going to disable user mapping for the purpose of the demo, hit the create, and now we have that open realm NFS policy. We're going to add a rule. We're going to make sure that all clients can access it. We're going to allow root ID to come in. We're not going to squash it. And we're going to use auth sys for right now. That's totally fine. Okay, so now we have rules, we have a server. Now we just need to associate the rules with the server. And so what I'm going to go ahead and do is select our server, realm 1, select my directory, root 1. For my export, I'm going to say sync file. This is what I'm going to mount for my client in just a moment. And I'm going to enable this right now. I'm going to hit create, and then all of a sudden, we have ActiveCluster with data being mirrored from one side to the next. There's a couple of more steps I want to do though. So if we go to protection, and I go down to my ActiveCluster here, and I look at my array, right now I see sub-interfaces. I only see 2 assigned, and that's not something that I necessarily want. I want to add an additional 2 Ethernet connections to this. And so I'm going to go and add those right now. I'm going to go to ActiveCluster, I'm going to go into the realm. We see our interfaces here, and I'm going to hit edit. I'm going to go ahead and select 2 more because we want file interfaces, physical Ethernet interfaces associated with that virtual interface across both controllers and both arrays. Here it gives me a default or a drop-down menu of interfaces that are available in pairs. I'm going to go ahead and select these. And I'm going to hit save. And now this is updated. The realm with the additional physical Ethernet information. So now we have 4 physical Ethernet ports. They are all supporting this singular IP address. And we should go to our client and be able to mount it, drive workload, and then see failover back and forth. Right? Okay, so talking about that, let's go ahead and start looking, get our performance screens up and running. File systems, we're going to drop it down to 5 minutes over here. We're going to do the same thing over here. File systems, drop it down to minutes. And now what I'm going to do is I'm going to go to our client. Here's our client. So this is a Linux client. I'm going to run the mount command. I don't think we have anything mounted via NFS right now. So I'm going to go ahead and mount the NFS file system that we just created and exported from that array. So here is that export that we had. We're going to go ahead and mount it on mount sync file. And we are done for there. If we go into that directory, it should be empty. All right, so we see an empty directory right now. And what I'm going to use is I'm going to use a dd command, a Unix utility, to drive a bunch of workload, okay? From here, I'll show you what the command is. All right, so we're going to, from this Unix client that we've mounted the NFS file system, we're going to take a bunch of information from dev-random. We're going to start writing it out to a file within our mounted NFS file system. And we're going to write a bunch of gigabytes to it just so we get some traffic. We're going to put it in the background too. And now we should see file stuff kicking off in just a moment from our here we are, from our systems. So there's a delay on the performance analysis side. If we go to the real-time side, we see traffic on VFA1 right now happening. If we go to VFA2, we don't see that traffic because VFA1 is serving all the reads from it right now, right? So again, I'll go to the file system perspective. We're going to drop down to 5 minutes, and we're going to show a workload. I mean, our workload is already running, but we're going to show it what it looks like from here. Okay, so that workload is still running in the background. I am going to now cause a failure condition. I'm going to simulate a failures within our simulators. Right now, we'll see cessation of the I/O. A failure condition. Wait a minute. There we go. Okay, failover condition has happened now. We should see I/O dropping. There it is. There's a cessation in I/O as we're having the failover command. Our DD operation, though, is still going. And if we go on to the other side, if we look for here, we should see the performance picking up right away in between the two. And if we look at the differences between the two, we see at 1846, an O2 dropping traffic from here. We go to the other V side VFA that we failed over to, and we see 1846.04, so super, super fast. That simulated network failure condition has still processing rights, but this is processing it on VFA2. the leader, where we were writing to begin with, was from the first flash array. Then we disconnected that flash array, simulating a failure. We saw the workload fail over automatically to the other side without remounting the file system, without DD stopping. There was a small cessation, there was a small pause, but that was about it. And so this is how simple it is to set up synchronous file solutions with Pure Storage's ActiveCluster for File feature that we're super proud to talk about. Thank you for giving me your time. I appreciate it.
And there you have it, a really solid overview of ActiveCluster for File on FlashArray. If you liked what you saw and you want to dig deeper, hit up your Pure account team, visit our website, and visit our test drive site to see how it works firsthand. Thanks again for taking the time to watch this video, and we'll see you next time on Pure 360.